Okay, how's everybody doing today? This is Mr. Massaroni. We're going to be talking about sequences and series. I know some of you are used to the melodious incantations of Mr. Higgins. You will have to suffer through my raspy voice here as we go through this first lesson and a few more after this. All right, sequences and series. We're going to examine sequences and their geometric and arithmetic sums. So we need to differentiate a sequence of numbers as opposed to a pattern of numbers, as the two differ in how we can handle them. A pattern is just that. It's a pattern. It's not an actual sequence. One of the ones you'll see, and I've shown this many times, a pattern you'll see like maybe a 0 and a 1, and then 0, 1, 1, 0, 1, 1, 1. That's a pattern. That's not actually a sequence. There's no mathematical way to get to one term from the other, okay? So when we talk about a sequence, it's a function whose domain is the set of positive integers, the function values a sub 1, a sub 2, a sub 3 to a sub n and on. And that's how we say it, a sub n, a sub 1. This is called a subscript, okay? So that's what how we refer to it. Those are the terms of the sequence. I'm sorry this video is not perfect. Trying to do some makeshift work here. I apologize. We do the examples, it'll be clear, but I'm sure you guys have this in front of you as I've posted it online. All right, now an example, we're going to write the first 5 terms of the sequence. A sub n is 2n minus 1 over 2n. So the first thing we look at is the first term, n equals 1. So we'll say a sub 1 is. Now what we do is when n equals 1 for the first term, we put 1 in for n. So it's a sub 1, 2 times 1 minus 1 over 2 times 1. And when you do the math, 2 times 1 is 2 minus 1, and 2 times 1 is 2. So the first term is 1/2. Now we do the second term, a sub 2. 2 times 2 minus 1 over 2 times 2. I'm sorry, I got an extra parenthesis here. And that comes out to be 3 over 4. So n equals 3. A sub 3 is 2 times 3 minus 1 over 2 times 3. You get 5 over 6. And if you continue that pattern out, 7 over 8, 9 over 10. Okay? You can work those through yourselves and go from there. Now, we want to write an expression for the nth term. So what it is an expression that says, hey, this is how to find when we say nth, we're referring to any term out there, the 5th term, the 10th term, the 20th term. Okay? We would just plug in the number like we did here back in 1. Okay? So when we look at these, the first thing we want to look for is this is our first term, our second term, our third term, and fourth term, and on, okay? I always first look for differences. Like from 2 to 3, you're adding 1. 3 to 4, you're adding 1. 4 to 5, you're adding 1. So as the term goes up by 1, the numbers go up by 1. And the same thing happens in your denominators. They all go up by 1. But when you see that they start in different spots. The numerator starts at 2, the denominator starts at 1. So what I'll do is I'll look at it. This is my first term. My denominator is a 1. My second term, my denominator is a 2. So when I go to do this, it looks as if my denominator is just whatever term number it is. The numerator is 1 more than that. Very simple, n plus 1. Okay? Now, when we do this third one, it's a little trickier. Okay? And what we want to do, again, it's the same thing. I always use my fraction 0 over 1. This is plus 1, plus 1, plus 1. Okay? Now, these are not going up at the same rate. So that means you're multiplying. From 1 to 2, you multiply by 2. To get from 2 to 6, you multiply by 3. 6 to 24, you multiply by 4, and that pattern continues. So you have to look at it. Your numerator is actually 1 less than your term number every time. So you can come up with n minus 1 there. Okay? Now, when you multiply by 1, and then 1 times 2, 1 times 2 times 3, 1 times 2 times 3 times 4, and on, if you remember, those are factorials. Now, I don't expect you to just pull that out of your hat, but understand that's how that works, okay? You've got to look for those patterns, the same things that go on, the multiplication, the addition, the subtraction, okay? And now I'm going to move on. A recursive definition is when each new term of a sequence is defined by the previous term, okay? And the most famous example, I'm going to say, is the Fibonacci sequence, where each term is the sum of the previous two terms, okay? And if you look, they define a sub 0 as 1, a sub 1 as 1, a sub 2 as 2. And then any subsequent term are the sum of the previous two terms. If you have k, the previous term is k minus 1, the term before that is k minus 2. So a sub 2 is a sub 1 plus a sub 0. We have those as 1 plus 1, you get 2. A sub 3, second term plus the first term, 3. The fourth term is the third plus the second, 5. And this goes on and on and on. Okay? Now, we're going to get into summation. And we have some definitions here when you look at it. Most of the time when you look at this, this is a nature of printing this out in Word. Okay, when you have summation, you usually see it like this. Okay, those are the same thing. All right, the I down here, we call the index. That's the term identification. Okay, that's where we start. The first term is 1. The upper limit is n. This is as high as we go. And the lower limit, we're starting at 1. This could be a 0, it could be a 3. Okay, if this were a 3, that means your first term starts with I equals 3. Okay, that's all that means. All right, and some of the properties we have, if you have your sequence is multiplied by a constant, then you can just multiply the sum of that by the constant. You can actually bring this constant out front, and if you are adding two things together in summation, you can take the sum of each individual piece. I say adding, this goes for adding or subtracting, okay? You can just break these up and do the sum of each individual piece. It's the same thing. You'll have no problem with it, okay? Now, moving on to do a little more work, I'm going to define an infinite series. Now, the infinite series, you'll notice, starts with 1 and goes to infinity, hence infinite. You have a sub I of your first, second, third, to I, and on and on and on, and it just keeps going forever, okay? Now, your finite, or we call the nth partial sum, has a definitive ending. We end at n. That's the difference. You have infinity for an infinite. For a finite, it tells you where to end, and it ends there. Okay? I'm not sure if all of you know, you see these dots like this, that means it goes on and on forever. All right? Now, arithmetic sequences. The definition, an arithmetic sequence is one whose consecutive terms have a common difference. So you see I've listed out my sequence here. Term 1, 2, 3, 4, and all the way on. And when you subtract the second term minus the first term, it's the same as the third minus the second, as the fourth minus the third, and we call that D, the difference. Okay, and that'll come into play in a minute when I talk to you about different equations on how to find these sequences. Okay, an example. Negative 2, 1, 4, 7, 10. We do 1 minus negative 2. That's the same as 4 minus 1, 7 minus 3, 10 minus 7, which is 3. So your difference is 3. Okay? Now when we talk about the nth term of a sequence, when I give you the sequence, I give you an equation. It's very similar to slope-intercept form. Okay? you have a sub n, say that's the 15th term, whatever your difference is, times n, whichever that is. In the example I gave you, it would be 15, plus c. All right, this difference is essentially your slope. You're going up up or down the same amount every term. And this c is equivalent to your y-intercept. Okay? It's actually your first term minus your difference. So if you take the difference away from the first term, you're actually looking at, I call term 0. Okay? That's not a perfect explanation of it, but that's what we're referring to. Whatever's before term 1, term 0. Okay? And now we can call the recursive formula is any term is the first term plus the number of terms minus 1 times d. Now this n minus 1 comes from the fact that if you're going to the third term from the first term, okay, your n is 3 because it's the third term, but there's only 2 differences between the first and the third term. The first to second, second to third. And anytime you have that, you'll see that n minus 1. Okay? Now I'm going to do some examples here with you, and then I'm going to wrap up this portion of the lesson. Okay? Let's work on this number 1 here. Given the formula for the nth term of the following sequence, give the formula. Okay, so what you want to do first is you want it to be a sub n is your difference times your term number plus c. So your difference here, to get from 5 to 8, you're adding 3 every time. Okay, so your difference is 3. Now you know your first term, or a sub 1, is 5. So if I look at this formula and I say my a sub 1 is 5, okay, so we'll do a sub 1 is dn plus c. We know this is 5. We know my difference is 3. That was my first term plus c. And if you have 3 pieces of this equation, you can always find the fourth. 3 times 1 is 3, so I will just skip that and subtract 3 from each side, and you get c equals 2. So when I come back up here, a sub n is, my difference is 3 times the term number plus term 0. Okay? So like you've done before, slope-intercept form, if I gave you the slope and a point, you can find the intercept. If I gave you an x-coordinate, the intercept, and the slope, you can find the y-coordinate, just like you've done in algebra and all the other courses you've taken. Now, we have something a little different here. I'm going to give you the 5th term, a sub 5 is 19, a sub 11 is 43. Write the first 3 terms of the sequence. Now what we need to do is solve, as always for some of these, we have a sub n is dn plus c. How many of these can we find? Well, we can find d. And how do we do that? We know from term 11 to term 5, you have 6 differences. Okay? Term 11 is 43. Term 5 is 19. You do that subtraction, it's 24. Check that. I'm a step ahead. 24 divided by 6 is 4. That ends up being your difference. Okay? Now, using any of these, I'm going to use a sub 5. So if we know a sub 5 is dn plus c, a sub 5 is 19. We have my difference is 4. I'm sorry. The term number is 5 plus c. So we go through and we do the math. 19 plus equals, check that, 20 plus c. Subtract 20. Your first term, check that, term 0, or c, is -1. Okay? So we know that a sub n equals 4n minus 1. Now, does that answer the question? No. It says write the first three terms of the sequence. So, a sub n equals 4n minus 1. A sub 1, 4 times 1 minus 1, which is 3. A sub 2, 4 times 2 minus 1, which is 7. A sub 3, 4 times 3 minus 1, which is 11. And those are the first three terms, so that's the answer to your question. Okay? And now the last example, given -8, -1, 6, 13, and on, find the 15th term. So I'm actually going to use a recursive definition here. A sub n equals your first term plus n minus 1 times the difference. Okay, so if I'm looking for A15, my first term is -8 plus number of terms minus 1, and I need to find my difference. What am I doing to get from -8 to 1? Adding 7, -1 to 6, 6 to 13, all plus 7s. So there it is. Now you just need to do your math here. 14 times 7, -8 plus 98, and you get 90. Okay? I'm going to break here, and I will come back. There's still 2 more parts to this lesson. We're going to talk about some geometric series and then proof by induction. Okay? Hope everything's going well, and good luck.